Okay, so why am I zoomed in on this little washer here? Well, I needed an end plate for the air filter element for my Quincy compressor. And I was looking on McMaster-Carr, and they had what you call fender washers, big washers with small holes, up to 3 inches in diameter. But the idea of the element was actually like 3 inches, so I need something more like 3.5 inches. And I ordered one of those. So as you can guess, this is not a little washer. I guess you better consider what you're buying sometimes, because this is just a monster thick, 1 pound washer. And what I have to do now is I have to weld a smaller fender washer with the 1/4 inch hole to the center of it. And this is my 1 pound end plate now for the air filter element. So let's go ahead and marry these two together permanently. Now, this is not something I am remotely good at. It's actually not half bad. Now let's wire wheel this and see what it looks like. Well, it is very hot, but in amongst the horrible welds, there's actually a few spots that look halfway decent. No filler. And really all I'm looking for is there's a stud coming through here. I just want that to be sealed, airtight, and I don't think those two pieces are ever going to come apart. So let's let it cool off. We'll take it over to the lot and get this attached to the air cleaner. Yep. That certainly will do the job. Won't win any beauty contests. Okay, we have our mounting bolts installed from the underside, countersunk. Everything should drop right on. There's probably a lot of you saying, that plate shouldn't be wood, that should be a steel plate. And you're right, it should be steel, but I don't have a piece of steel. And to be honest, this piece of wood has been on the Westinghouse setup for probably 15 years, and it didn't go anywhere. So I think it is most likely fine for the service that it's going to see. Okay, mounted and secured. I don't know that it matters, but these belts have like a little bit of a set where they have a tight radius and a big radius from being sitting on the pulleys. I'm going to stagger those in different orientations so that it doesn't thump. Now let's see how our tensioner works. Feels pretty good. Now what's probably happening as we're tightening this up is the motor is skewing this way because there's some slop in the bolt holes. So what I'm going to do is I'm going to lock the back corner and then give it another little bit final tightening and see if we can square that up, and we'll check it with the straight edge. Tension-wise, that feels pretty good. It's actually much better. So what I'm going to do now is tighten the remaining 4 from the underside, and we are ready for power. Unfortunately, I do not have the correct plug for the 240 output of my generator. I've never used that. It uses an L1420. So I've got one on order from McMaster Car, and it's going to be a day or two before that comes in. So stay tuned and we'll wrap it up and we'll power it up. I'm going to use a flare fitting for the air connection to the regulator. Seems to be that compression fittings, copper compression fittings, are more the norm on compressed air systems. But I tell you, in my opinion, a flare fitting is a little bit more robust, able to be taken apart and put back together more times without it developing a leak. There's little copper compression rings. If you try to loosen those and tighten those, you got about one or two retightenings, and then they're done. Let's get the smaller crescent wrench. The flare fittings, I use those all the time on fuel lines, oil to the furnace and from the tank. I tell you, I've never had one of those leak, and taken them apart dozens of times, reused them. These flare fittings are from an oil, fuel oil system. I'm just going to kind of work with the geometry that is already in this line. And just gently reshape this. And we've got to come over to here. All these lines remain pressurized. So if you want your tank to maintain pressure, all these fittings have to be tight and leak free. I don't know if this line's going to be long enough. If it's too short, it's going to be just barely too short. It's going to be just long enough. And we can make that work. We do have to get the nut on, get that squared up and flared. One thing you can always do is install this and work the line in reverse. This enables you to hold it and get some little bit of bend in those last few inches. Once both sides are connected, you can snug everything up, and then that'll give you some rigidity. You can make some final tweaks to the positioning of the tubing. Just basically looking for it to be not rubbing any other areas. Fairly pleasing. Also would like to ensure that we can get the air filter on and off. Okay, no problems there. That looks pretty good. So I'm going to leave this end off, and as the tank pressurizes initially, I'm going to blow out this line real good. We don't want any debris that's in here to go up into our regulator. There's a male adapter 1-inch hose to 3/4 NPT. And at the upper end, 1.25 NPT to 1-inch hose. So this compressor can be belted anywhere from 400 to 900 RPM. I have a 5-horse motor, so I've got it in the 500 RPM range. I think my plan will be one day when I get a 10-horse motor, get running on 3-phase. I believe I will then change this setup. Let me back up here a bit. I'll go from the 1.25". I mean, right now we got 1.25" to 1-inch hose to really 3/4-inch pipe fittings. So if I, down the road, put 10 horsepower on this, and we're pushing more like 50 CFM, I'll get new fittings. I'll get an 1.25" hose. I'll take the check valve out and go straight into the tank with 1.25" hose, so we don't have so much restriction. But for now, running at a pretty low RPM, I think we'll be all right with the 1-inch hose. That'll be a nice bend. All right, let's get the tools cleared off of here and get the generator dragged over. Unfortunately, I have to try to run this on the generator. It's going to be near the limit of what the generator can put out, so no guarantees, but let's see how we do. Well, the generator just doesn't have the oomph to keep it running. I tried taking a couple belts off, and I also can't seem to get the belts tight enough. It could be that they're just old and worn out and they got the permanent set in them, but I was reading 30 amps, and the motor is only supposed to draw 20 amps full load. So I don't know if I got a motor issue, if I just got a not enough power issue, if I'm getting voltage drop. Could be a number of things. I might just have to wait for Virginia Power. Might also try to just take the belt off and run the motor alone and see if it will it'll work with just the motor freewheeling. So disappointed, but everything mechanically looks like it should be fine. Try again. right, I cheated. I didn't have success running the single phase motor, couldn't get enough current through it to get it off its starting windings. So I put on the 3-phase motor that came off of the Westinghouse air brake. Got my new banded belt, which seems to have solved the vibration issue. Now I just discovered that, yes, I do have a tank drain, or it did have a tank drain, because when I got up to 50 PSI, you heard it blow, and what that was all the rust and scale on the bottom just blowing through the hole where the tank drain was. So I took a look under there, and the fitting itself is broken off inside the female pipe plug. I'm going to see if I could get the remnants of it out with an easy out and retap it and put a plug in there and get this thing up to pressure. Well, got the tank charged up to 150 pounds. You're gonna have to learn about this regulator a little bit because it lets the compressor motor stay running, and it just starts to unload the air into the air cleaner. So I got to read up on that a little bit, but everything seems to be good. The amperage of the motor is under the full load amps, so the speed that I chose for the 5 horsepower seems to be about right. I'll have to retension this. But it looks like we're good to go when we need air. I'll see how long it holds in the tank.